We're now going to do special cases of factoring. One is difference of squares, and the other is what's called perfect square trinomials. We're going to do difference of squares at first. Difference of squares, if I were going to do a grid, it would look like this. It's the difference between two expressions that have been squared. So for example, if I put an x here and a 3, this is x squared minus 3 squared is 9. That's considered difference of squares. If I ask you to factor x squared minus 9, I do my rewrite. I see that it's difference of squares. I see x squared was x being squared, 9 was 3. And the factors are, I'll have x in both. And if we notice here, we have a minus 9, so I'm going to have 3 in both. One is plus and the other is minus. And what you'll notice is when we do the inner and the outer, we have no x term. When I do the inner and the outer, I have 3x, and negative 3x means there's 0x or nothing. And sure enough, that's our x squared minus 9. It's a binomial it's really a trinomial where the x term is 0. And this is called the difference of squares factor. In general, if we have a squared minus b squared, it's going to be very straightforward to get the factors. We just put a and b in both. One gets a plus and the other gets a minus. And that's so that the inner and the outer will disappear. And we just are then left with a squared and minus b squared. The key to doing these is you've got to have the rewrite where it's something squared minus something squared. That's going to identify what goes in each of the binomials. So for example, if I said factor 4x squared minus 1, the first key step is I've got to get a rewrite. My rewrite means I've got to write it as something squared minus something squared. And I have to think, what squared gives me 4x squared? What squared gives me 1? Looking at that, how I got 4 is I had 2 and I squared it. How I got x squared, I had x. How I got 1 was 1. This rewrite now has identified the a and the b. Now I can proceed and I can put, I'm going to have two binomials. In both binomials I'll have a 2x and a 1. 2x and a 1. One gets a plus, one gets a minus, and that is the factorization of that difference of squares. Now we'll do what's called the perfect square trinomial. Now, perfect square trinomial is coming from we have some expression, a plus b, and we've squared it, and we get an answer. We get a trinomial. Let's do an example. If I said x plus 5 and I squared it, we know we get that from x plus 5 times x plus 5. In working this by foiling it, we're going to do x times x, x squared. 5x and 5x, because it's the exact same binomial, it gets doubled. 5x and 5x, so that's 10x. And then our last term, 5 times 5, is 25. This result is called a perfect square trinomial. And we can see it because you had the last number was squared, 5 times 5. This was a square. And then the inner and the outer we doubled. Let's do one. Now we're going to go backward from here to factor it. So let's look, for example, if I say x squared plus 12x plus 36. Well, we certainly know that it has to come from x and x. For this one, I can see that this is the square of 6. This is 6 squared. So if I put in the plus 6 and the plus 6, with the inner and the outer, I double it, and I get 2 of those, give me 12x. This is called a perfect square trinomial, and I factor it, and we can actually write it like this, x plus 6 squared. We'll go on and do another one. Suppose I wanted you to factor the perfect square trinomial x squared minus 14x plus 49. The only way we can get x squared is with the x, but it's called a perfect square trinomial. This is the square, so I know that's going to come from 7. But because this is negative 14, what am I going to put in but negative 7? We can see that's true because you'll have negative 7x and another negative 7x. Negative 7x and negative 7x is negative 14x. So there it is. And we can write that factor as x minus 7 squared.